All right, you're welcome to Maths Demystified. I have decided to make this lesson into a video so that you can always remember this topic. It's a major topic and I really want you to master it. So I need you to be able to go back to the video. You can replay it, you can rewind it, you can pause it until you perfect it. All right, I know some of you were not around when I taught the topic. We have very few of you in class. So please, you will soon be writing your exams. So I really want you to pay attention to master all these things I'm going to be teaching you today. I want to deal with areas of some basic plane shapes. Areas of some basic plane shapes. You know the perimeter already. Whenever you're asked to find perimeter, you just sum up the surroundings. Sum up the surroundings. Say you want to find perimeter of this kind of shape, right? You just sum up the outer part. This is the part. If it's 1 centimeter, add it to the next one. Assuming this is 1.5, assuming this is 3, you just start adding from outside, and that's it. If I do like this and I call it 5, you will not add this one. You will not, because it's inside. Can you see? So you only add the outside. So if I have something like this, you will just add this to this part. That is perimeter. So I'm not going to be dealing with perimeter today. I want to deal with area. So, for some basic shapes. And I just selected those shapes because they are the common shapes that they always ask you to find the area. Number one, I want to start with the one everybody is pretty much used to. So if you have a circle, the area of common plane shapes. The areas of common plane shapes. So, say you have a circle. The area of a circle will be pi r square. R square, and just like that, r square. So if I have a circle now, and you are told that the area of this circle is, the radius of this circle is 3.5, and I say find the area. So the area will be pi, which is 22/7, times the r. I wrote 3.5. 3.5 can be written as 7/2, and it is supposed to be squared. So I write it again, 7/2 pi r square, and that is all. Pi, 22/7, radius. Your radius is 3.5, that is 7/2. It's just squared, write it 2 times. And you cut to the lowest. Cut to the lowest. This can cut this, you get 11. So this times this will give you 77/2 centimeters square. So you can cut this one 2 to the lowest. 2 will go here how many times? This is going to be 3. Remaining 1. 2 will go is 17. That is 8 times. And remaining 1 again, add 0 to it, and that will be 0.5 centimeters square. And that is how to find the area of a circle. Number 2, to find the area of a triangle. To find the area of a triangle, the area of a triangle is half base times height. Half base times height. The kind of triangle I'm talking about here is a right angle triangle. That is the one you need for your level. The right angle triangle. Use half base times height. And let me tell you something. When I ask students where is the base, they will say this is the base. Where is the height? This is the height. Now, I also want to tell you that there are different ways they can draw this triangle. What if, if I draw a triangle like this now, this place you have 90 degrees. Either this or this is the base or height. So I can call this the base, call this one the height. And I can also change it and call this one the base, and this one the height. Okay, why? Because, okay, say I redraw this now and I make it like this. Once you see 90 degree, that tells you it's a right angle triangle. So where is the base now? You can't say this is the base. All right. So how do you know the base and the height? You look at the 90 degree. That is what will tell you where the base is. This 90 degree. So those lines that form the 90 degree, one of them is the base, one of them is the height. Note what I said. Those lines that form 90 degree, one of them is the base, one of them is the height. So in this, there's no need to bother yourself. You can call this one the base and call this the height, or the other way around. All right. I can even draw it like this. All right. So if I ask you now, where is the base? This can't be the base. This cannot be the base. So it's either this or this as the base, and it's either this or this as the height. So I can call this the height and call this the base. Please take note of all these things I'm saying today. So please really take note. Okay. Now, sometimes they will draw the diagram in this format. Let me show you. They draw a diagram like this. And you have something like 3 here. Say you have 2 here. Say find the area. Area equals half base times height. Where the base, I can say the base is 3 and the height is 2. So when I cut, I will have 3 centimeters square. That is one type. Sometimes they can also draw the triangle, the same triangle, like this. Now, if you observe this, you will discover that there is no 90 degree. So you cannot use half base times height to solve this yet. Now, this is what you now do. There's no base here and there's no height. But when they do like this and do like this, now you have base and height. You have base and height. In this case, this one becomes your base straight away. And this one becomes your height. Please pay attention very well. In this type, this one becomes your base, this one becomes your height. So if you call this one 2 centimeter and call this place 5 centimeter, for example, my area will now be equal to half base times height, which is equal to half times my base is 5, my height is 2. If I cut this one, I will have 5 centimeter square. I really need you to take note of these triangles I'm drawing. I need to take care of the triangles I'm drawing, because some students, when you ask them to find the area of this kind of triangle, they have problem with it. Let me draw another one for you. Another type of triangle you are likely to see in your exams. They can also do something like this. They can do something like this. Like this. You can see there's no 90 degree, but then they can now do something like this. Come over here and do something like broken line. And you can put something like 3 here. And from here alone to this place, say from here to this place, from that line, they can now say this one is 7 centimeter, for example. You say find the area. In this case, your area is C half base times height. Why? There's a 90 degree here. So where you have 90 degrees, this one here becomes your height, and here from here to here becomes your base. This one is not included though. Even when they put a value here, they have put broken lines. This broken line means that it is not part of your diagram, but the height of this diagram is 3 centimeter, and the base of this real diagram is 7. So if you are now solving it, that will be half base times height, which is 3. So in this case, you can cut. This one will give you this one to be 3.5. Okay, 3.5. Or you can just leave it the way it is and solve it straight. Let me leave it the way it is and not stress you. This is half times base times height, which is 3. So here I'm going to have 21 over 2, and that will give me 11.5 or 11.5 centimeters square. That is how to solve this. So these are the basic type of triangles you will see. Sometimes they will give you the one where you will have the rectangle triangle showing, or they can just make it like this. Please take note of this. All right, sometimes you can have a square. Number 4. You can also have a rectangle. They look alike. In a square, all the sides are equal to themselves. All the sides are equal, and these places are 90 degrees like that. In a rectangle, the opposite sides are equal, not all the sides. Here too, you have 90 degree, where this one is equal to this one, and this one is equal to this one. So this is the longer part, length. This is the breadth. This one, you can call it anything. I can call it length. Everything will be length, 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 length. If I call it breadth, it will be breadth, breadth, breadth. If I call it x, 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 x. So the area of this one is L square, meaning L times L. And the area of this one, can you see, is length times breadth. Please take notes. Take notes. So I'm not going to give an example on this. Should I give an example? Okay. Let me just give an example. So let's assume that the length here is 2 centimeter. Let's assume that the length here is 5 centimeter and the breadth here is 1 centimeter, for example. So if I want to find the area of this, sometimes they'll just give you, if it's a square, most of the time they'll give you the length of one of them because they know that everything is the same thing. So in this case, it is just 2 times 2, and the answer is 4 centimeters square. And in this case, it is just 5 times 1, and the answer is 5 centimeters square. So please take note of this. Next, let's see the area of a trapezium. Trapezium. Now, most of the time, you will see them draw a trapezium like this. And many of you are used to it. Now, you see a 90 degree there. That's it. And sometimes, too, trapezium can also be like this. All right? Can also be like that, where you won't have any 90 degree. Something about trapezium is that this and this, these two lines are parallel to themselves. That's something about trapezium. The lines are parallel to themselves. So I can even call a square a trapezium because at least two lines are parallel. I can call a rectangle a trapezium because at least two lines are parallel. All right. So what is the area of a trapezium? The area of a trapezium is height over 2, then a plus b. Some will say half a plus b h. It is the same thing as this. That is the area. So your business is to now locate what the A is, what the B is, and what the H is. So in the top here, you know the parallel lines, one of them is the A. So this is the A, this is the B, this is the H. The H we are talking about is the perpendicular height. So since this one is the perpendicular height, you see 90 degree there, that is the height. That is the height I'm talking about. So if you come over to this place, the A is given, the B is given, but the height is not showing. So in this type, they will always show you, give you a height to help you out. So that one becomes the height. Please take note. So when you do a trapezium like this one becomes the height. It's not this one. They can give you this value. That is not the height. This one becomes the height. Please take note of that. And that is it. It's as simple as that. So what do we do here in this case? Very simple. Say I call this place 2, and I call this one, say I call it 5. And here, let's call this one 1 to make life easy for ourselves. And they're all in centimeters. Come over here too, say we have this one to be 3 centimeters. Say the whole of this B is 5 centimeters. And let's call this one 2 centimeters. So let's find the area. The area in this case will be, I said height, and the height here is 1. So 1 over 2. A here is 2, then plus B. The B here is 5. So if I do this, I'm going to have 7 over 2, which gives me 3.5. 3.5, sorry, there's no point there. 3.5 centimeter, which you can write as 3.5 centimeter. And you put the square there because it is area. Similarly here too, you want to find the area. That will be h over 2, a plus b. Here we have the height to be 2, and the base to be 2. Sorry, the height to be 2, we are divided by 2. And the a is 3 up there, plus the b, which is 5. And you have 1, because 1 divided by 1 is 1, and this is 8. and your answer is 8 centimeter square. All right. Now, there is something I also want to show us, because sometimes they will ask you to find the area of a shaded portion. The area of a shaded portion. See, shaded, shaded portion or shaded portion of parts. Area of shaded portion. I'm going to use a circle as an example. If I have a circle now with the radius here, let's call it capital R, and I have another circle drawn from the same center. Maybe it's a smaller circle here, and let me call the radius of this one small r. All right, and this place is shaded, and asking me to find the area of the shaded portion. So area of this shaded portion is area of the bigger circle minus the area of the smaller circle. What I'm saying is, anytime they give you a shape and a part of the shape is shaded and they're asking to find the area, what you do is simple. Now, you find the area of the whole shape, the bigger shape, the way you're looking at it, area of the bigger shape, minus the area of the empty part. That part too will form a shape. So in this case, the area of the bigger shape is a circle. So I'll use pi r, I'll use capital R square because the radius of that one is capital R, minus area of the empty, the part that is empty. That part is a circle. So I'm going to use the same pi small r square because the radius of that one is this. So say that you are given the capital R to be 10 centimeter and the small r to be say 8. No, let me not use 8. Let's say 6 centimeter. And you want to solve this. That will be 22 over 7 times 10 times 10. Okay, minus 22 over 7 times 6 times 6. Right? So in this case, we're going to have 2 times 100, because this is 100. All right? Divided by 7 minus 2 times 36 over 7. So just punch your calculator, get the answer. Punch your calculator, get the answer, and put centimeter. And that's it. It's as simple as that. That will make this part to become 314.29 minus, let me solve the other part, 22 times 36 divided by 7, and that gives me 113.14. And if we look at that, that gives me, give me a minute, 113.14, and that gives me 201.15, 201.15 centimeter. I'm dealing with area. Don't forget to put your square there. Okay, next we want to deal with volume of some common plane shapes, solid shapes. Volume of some common solid shapes. So volume of some common solid shapes. We shall be dealing with cylinder. We shall also deal with a cube and deal with a cuboid. Then one more, a cone. Just these three. Okay, we are dealing with these three. So let me give you the volume straight away. Maybe that will help us. So the volume of this, the volume of a cylinder will be pi r square h. Volume of a cube will be L cube. The volume of a cuboid will be LBH, and volume of a cone will look exactly like this, with 1/3 attached to it by r squared h. Let's get to work. So if you are given this kind of a cylinder and they tell you that the radius here is 3.5 and the height here is say the height is 7 centimeter, and you are looking for the volume. The volume will be the area of the base times perpendicular height. Area of the base times perpendicular height. The base is a circle by r squared and times height. So, and that will be 22/7 times the radius is 3.5, which is 7/2, and the set square, so 7/2 times the height is 7. So if I do this, this 7 will cancel this 7. Okay, this will cancel this to give me 11. All right, let me make this one 14. Let me make it 14. So that means this place will be 14. So this will cancel this to give me 7, so that I will have 11 times 49. Let's quickly work this out. I want you to get used to working it manually. This is 1, 4. This is 9. This is 4. When you solve this, you're going to have 1, 3, and this is 5. So 5, 3, 1. 5, 3, 1. Did I make any mistake here? Oh, I think I made a mistake. Imagine that. 1 times this is 9. Yeah, 49. Yeah. So this is going to be 9. And here it is going to be 9. Okay, centimeter cube, because we are dealing with volume. If you are dealing with area, that will have a centimeter square. Okay, that's all I want to take here. And please do not forget that they won't always bring the question like this. Sometimes they can give you the volume and ask you to find the height. For example, let me rebrand this question. Say that you were given, say that you are told that the volume equals 539 and the radius equals 3.5, and you are asked to find the height. You are asked to find the height, and it's a cylinder. You write the formula for a cylinder, write pi r squared h, then put the volume you are given 539, which is equal to 22/7 times the radius given to you. That is 7/2 times 7/2, and the height will become the unknown. So if I'm looking for the height right now, you know I'm going to cross multiply, and that will give me 539. This will come up times 7. This will come up 2 times 7 times 2. This will come up here 2 times 2. Then divided by all this will go down because I'm cross multiplying, and that will be 22 times 7 times 7. All right. So all you need to do is to cancel. This is 11. This cuts this one. All right. This will also cut. Before you know it, your answer will be what? Will be 14. Your answer will be 14 because that's what you have. So if you look at it critically, that's what you're going to have. This one we cut this one, gives you 11. This we cut this. Okay. Let me cut it again. Let's take our time to cut this so that you can see what I'm talking about. Let's take our time and cut this. Five, 3, 9 multiplied by 7 by 2 by 2 over 2 times 7 times 7. All right. So this we cut this. This we cut this 11 times. Are you following? So this times this will give me 77. So 77 we cut this one 7 times. All right. So and that will give you 14 centimeters. And that is so. It's not all the time that they will be asking you to find the volume, find the area. They can give you those things and ask you to find the other elements from the formula that give you the volume or the area you're looking for. So please always take note of that. All right, very quickly, if I have a cuboid, say I have a cuboid, and I'm told that the cuboid is of length 2 centimeters no, one of the side is 2 centimeters and it's a cuboid. And you know that the volume of a cuboid is L cube. So that will just be 2 times 2 times 2. And the answer will just be what? 8 centimeter cube. It's as simple as that. Let's look for a cuboid. If I have a cuboid and I'm given the dimension, so I'm trying to draw a cuboid here, just don't mind me. So I have that cuboid, and you are given this length here as length to be equal to 6 centimeter, the breadth here to be equal to 2 centimeter, and the height, the perpendicular height here, happen to be says 3 centimeter, like what we just did. And say volume will be equal to length times breadth times height. So the length is 6 times breadth is 2 times this 3. And that is just 12 times 3. 12 times 3, and that is 36 centimeter cube. It's as simple as that. Let's get to the last one. Cone. If you are given a cone, say you are given a cone, and the radius here is 3.5. Don't mind me, I'm using 3.5 a lot today, just to make the calculations easy for us. So, and the height, say the height is 7 centimeter. 7 centimeter. And let me even use 14. Say it is 14 centimeter, like we used in the other cylinder. Now I'm asked to find the volume. Volume is 1/3 pi r square h. 1/3 pi r square h. Okay, so what would this be? 1/3 times 22/7 times the radius there is what? You see the radius is 7/2 times 7/2 times 14 times 14. Just substitute. That's what you need. This cancels this. This cancels this. You get 11. This cancels this. You get 7. Like we got in the other one, it's going to be 1/3 times. I think we got 539. 539, if I'm not mistaken. So you need to just divide. So when you divide, whatever you now get gives you the expected answer. So in this case, it's going to be 539 divided by 3, which gives you 179/2/3. 179/2/3 centimeter cube. So that takes care of the shapes that we want to treat today. And I told you we're going to treat 4 shapes. Those are the formulas and how to go about them. Next, I want to show you the area of these common solid shapes. Areas of common solid shapes. So let's do the areas. Let's pick the cylinder that we did. Now, this part is a square, so it's pi r square. Here is a square, that's pi r square. Here is a curved surface, and it's 2 pi r h. 2 pi r h. So don't forget I said this one is curved surface area. So if you are asked to find only the curved surface area, this is the only formula you're going to be using. In this case, I'm not going to be giving any example. I'll just give you the formulas, and that's all. So if you're asked to find the area of this shape, my hand can touch this place, and that's pi r square. This is under pi r square. This is 2 pi r h. You just put them together. So the total surface area of this cylinder is pi r square plus pi r square, which is 2 pi r square, then plus 2 pi r h. That is the formula. So you just introduce the radius given to you and the height given to you, and you get it solved. Let's look at the second one. If I have a cube, we've got a cube like that, where everything, all the lines and everything, all the sides are equal to themselves. Have a cube. So if I have a cube of 2 centimeters, maybe one of them is just 2 centimeters like this. So that means that all the sides 2 centimeter like that. Now that means if it's a cube, each of the faces is a square. Do you understand what I'm saying? If it's a cube, each of the faces will be a square, like you're seeing this square now. So every one of them is a square. So how many squares do I have? How many squares do I have? If you look at it very well, you see that you have 6 squares. Take your time and look at it. This place and this place, that's 1, making 2. 1, making 4. Then 1 at the back, 1 in front, making 6. So that will be 6 of L square. 6 of the L square. So in this case, it will be 6 of 2 squares. Because L squared, if this one is L, that's going to work out. So that will give me 6 times 4, and that will be 24 centimeters square. In case you were given something like that. So that's how to find the area of a cube. And if you are given a cuboid, say you are given a cuboid of this format. I'm writing up the lesson right now. Given a keyboard like this, say I have something like this too. I have a keyboard where the length is given to me, the breadth is given to me, and the height is given to me. Let's say 5 centimeters, 2 centimeters, 3 centimeters. All right. So for me to find the area, you have to be careful too and pick. So the area in this case, you see, this shape and the one down are the same thing. They are both length, breadth. So length times breadth, there are 2 of them from the top and from down. So 2 length, breadth. So if I want to find this one too, it's going to be breadth and height, and there are 2 of them. Breadth times height, and there are 2 of them. So 2 breadth times height. Okay, I've done this part, I've done this part. It remains the front and the back. So this part for the front is length, this part for the front is height, and there are 2 of them. So 2 length times height. If you look at it, you see 2 is common to all of them. So you could just write length breadth plus breadth height plus length height. So either write it like this or write it like that. So all you need to do is substitute whatever you have into the formula. And you have 2 into 5 times 2 plus 2 times 3 plus 5 times 3. And in this case, I will have 2 into 10 plus 6 plus 15. And that is 2 into, this is 25, 31. And the answer is 62 centimeters squared. If I didn't make a mistake, and that's what it's going to be. It's as simple as that. You can rewind the video if it's too fast for you and learn it properly. All right, let's find the area of a cone. Got a cone like this. If I have a cone here, this part you are seeing is a circle. So the area of a circle is pi r squared. And this part is the curved surface area. And it is pi r l. Pi r l. The L there is this part. The slant height is called the L. Okay? So this pi r squared, this pi. Don't forget there's one height here. That is called perpendicular height. That one is h. We don't need it here. So for me to be able to find the total surface area, if they ask me to find the curved surface area, that's the only formula I will use. For me to be able to find total surface area, it will just be pi r squared, the area of this, plus the area of this, and that is pi r l. So whatever value they give you, just substitute it inside, and you are done. That will be all for today.